All right, so I want to talk about two of the questions that were on the 10.3 Check-It quiz that did not go so well. All right, this first question, if you want to look back at the quiz, is question number 1, actually. Okay, basically we're given 3 series here and asked to determine which of these series can we use the nth term test to determine divergence. So the nth term test can be used to determine divergence for which of these. Remember that the nth term test basically says if we know, as n approaches infinity, that a sub n approaches something that is not 0, basically, then the series diverges. Okay? Let's tear each of these apart then. Okay, let's start with that first series. If I take the limit as n approaches infinity of the natural log, so I keep calling it n, k for these up here, k approaches infinity of natural log of k plus 1 over k. If I think for a second, hey, what is this limit equal to? Well, as k is approaching infinity, the top's approaching infinity, the denominator's approaching infinity, and k are the same strength, so I really get that this limit approaches the natural log of 1, because we're thinking about the k over k there. As k grows, k is going to go on top, k is going to go on the bottom, they're going to go to 1, so this is really natural log of 1, which is 0. So we got 0 as our limit. Can we use the nth term test to determine divergence? No. 0s are sort of inconclusive, got to use a different test thing. So I is out, okay? I is out. Not to that one. All right, let's move to our next limit here. Let's do, for number 2, this would be the limit as k approaches infinity of negative 1 to the k over 2k plus 1. Okay, interesting. Well, as k goes to infinity, this negative is going to flip back and forth. It's going to alternate our sign, right? So we'll ignore that for now, but this part maybe we can think a little bit through. K over 2k, those are going to grow at the same strength. So really what's going to go on here, if k over 2k, our dominating term on top is k and dominating term down there is 2k, this limit we can really think about as equivalent to negative 1 to the k times k is going to win on top, 2k is going to win down there, the k's will cancel out 1/2. And as k goes to infinity, what's going to happen to this? Well, the limit's not going to exist. It's going to keep alternating, right? It's going to keep flipping sign. So here the limit does not exist. So I do know that this series up here, number 2, does diverge. Okay? So that one's okay. Let's test the last one. For number 3, the limit as k approaches infinity of 3k squared minus k cubed over 5k cubed. Maybe one tricky thing here is that our dominating term up top is actually the second term, and the dominating term down here is this one. I think some people might have chosen 3k squared as our dominating term up top, but it's not. The limit as k approaches infinity of this one in terms of our end behavior model is really like negative k cubed over 5k cubed, which reduces to negative 1/5. All right, we got something other than 0. So this means that the series of these terms will also diverge. And so our 2 divergent series are 2 and 3. All right, 2 and 3. 2 and 3. Okay, I'll leave that there for a second. The other problem that caused some struggle was question number 3. So for this one, just keep in mind our limit as n goes to infinity is what we're looking for. If it's anything other than 0, it means that series diverges. All right, we got to be okay with the alternating, just kind of leaving it there and making sure we select the appropriate largest term. Okay, let's look at question number 3 now. Question number 3 was a little more conceptual, and I know what went wrong there based off of the answers that I saw coming in, okay? Essentially, question number 3 was asking us if we have some term that we know equates to f of n for some function, if the series converges to k, what do we know? What do we know then about other things? In particular, what do we know about the integral is really what this question is getting at. Remember that f is positive, decreasing, and continuous, so the integral test does apply. That's kind of the key here. The integral test applies. Now here's the thing. The answers really came down to whether or not people felt like the limit as n approaches infinity of a sub n equals k. Or there's another group of people who felt that the integral from 1 to infinity of f of x dx equals k. Right. And there's a group of people who felt that the integral from 1 to infinity of f of x converges is what we know. Now here's the important thing to remember. This is really forcing us in the direction of using the integral test because they tell us that f is positive, decreasing, continuous, so the integral test applies. Now here's the big thing. The integral test. What does the integral test actually tell us? It tells us that if we have some sum that converges, that the integral of a function that follows it basically, that the integral converges. It doesn't actually say that the integral converges to the same number. All right. All we know is that they both converge or they both diverge. Okay. They both converge or they both diverge. So we actually have to remove this as an answer. This is no good for us. This is saying, hey, the integral converges to k. The sum was to k, so the integral converges to k. It sounds like it will make sense, but this is not necessarily true. The integral test does not say that they actually go to or evaluate to the same number. So this answer choice is no good. This is kind of acting like it's our nth term test, but the nth term test, if the series a sub n converges to k, k might not be 0. K could be 2, and in which case, if the limit as n approaches infinity of a sub n is 2, then this doesn't match up with the series converging, all right? So this doesn't work for us. The only thing we can conclude then from this question is that the integral from 1 to infinity of f of x, dx, almost forgot my dx, Mark Walter, that integral from 1 to infinity of f of x dx converges. That's the only thing we can actually tell based off of knowing this information about the series and that the series converges to k. We cannot tell this, and this was the big distractor. We cannot tell what the integral converges to based off this information. Please file that away, make a note of it somewhere, add it to the 10.3 packet. That's big information. The integral from 1 to infinity of f of x dx does not have to approach k just because that's what the series converged to. All the integral test says is that the integral converges. Okay? All right, hope that helps, and I'll talk to y'all later. Bye.